All right, so let's go ahead and work this, this relative motion example. It's the problem of the boat crossing the moving stream. And remember, if we're doing a relative motion problem, it's just basically a vector addition problem. Okay, so this is our equation describing relative motion. The total velocity relative to some fixed observer is equal to the velocity of the object relative to some kind of moving reference frame, and v is the velocity of the moving reference frame. So here's what we have going. This is the situation that we had in that figure in the lecture. The boat is attempting to cross straight across the creek. The stream is moving downstream, and so we've put on a y and an x-axis for that. And the velocity observed by someone standing on the shore would be then the sum, the total vector, and it would be at this kind of angle right there. So when we do this problem, we need to identify what these symbols mean. So remember the relative velocity, that would correspond to the boat that's directly trying to cross the river at 1 meter per second. This vector is the moving frame, that's our river, and it's moving downstream at 1.5 meters per second, as shown in the figure here. So remember, if we're doing vector addition, just like in the last example, we need to add the components. Okay? So the total x component then, we need to figure out what its x component is. And we need to figure out what its y component is. Okay? Well, the x component is just the sum of the x components of these vectors. So it's the relative velocity x plus the moving frame x component. And the same is true with the y components. Okay? So now all we need to do is figure out what the x and the y components of these are. And this is actually, the setup for this problem is relatively simple. We don't actually even have to resort to cosines and sines because we can kind of just pick them off the plot. So v relative, remember, is the boat velocity. And the boat velocity is entirely in the y direction. So if we're asked about the x component of this is 0. Okay? Because the motion is entirely in the y direction for this one. Okay? Now for the moving frame, the x component, well, the moving frame, that motion is entirely in the x direction. We've defined the x direction as downstream. Okay? So the x component of that then is just our 1.5 meters per second that was given in the start of the problem. Okay, now if we're asked, let's look at the y. Well, you sum these together and we get 1.5 meters per second for the x component of our total velocity. Now for the y components, the relative velocity vector, that is the boat, well, the boat's motion is entirely in the y direction. So the y component is just our 1 meter per second that we were given in the problem. So this would be 1. And the moving frame, the y velocity, well, that moving velocity, the river, it's entirely in the x direction. So therefore it has 0 y component. Okay? So that gives us then a y component of our total velocity of 1 meter per second. And so that's kind of what we expect when we look at this figure here. This would be 1.5, this vector, this would be 1. So here's our total velocity then, if this is our kind of y-axis here, and here's our x-axis. Well, this is 1.5 meters per second, this is 1 meter per second. And we're asked to find this angle here. We're asked to find the magnitude and direction of this vector. So if we want to know what the magnitude is, the length of that vector, well, we just use the Pythagorean theorem. And again, what that means is the total velocity is the square root of v total x squared plus the y component squared. Okay? So it's this squared plus that squared. That goes in here. So 1.5 squared here, 1 squared here. Add those together and take the square root. And what you get then is 1.8 meters per second. Okay? So there's the first part of our answer. We found the total velocity of the boat relative to an observer on the shore. Now we need to know the direction. What is this angle theta? So what angle is that boat making with the shore? Okay? So we know the boat's trying to directly cross the stream, but the stream's carrying the boat downstream. So as a result, our total vector is in this direction. And so this angle then is found in the standard way for vectors. It's the arctangent of the y component divided by the x component. Okay? And so our total y component is 1. Our total x component is 1.5. So we take 1 divided by 1.5 here, and then we take the arctangent of that. And the angle we get then is 33.7 degrees. So there's the direction the boat takes. The boat makes an angle with the shore that's 33.7 degrees.